In the last video for this unit, we're going to be looking at how you write the names. So if you're given a formula, how do you convert that into the names of those elements? So like anything, there are some rules or steps to this as well. So you're always going to write down the name of your positive cation first. So because these are ionic compounds, that should always be a metal. Metals are always positive. And if that cation is one of your transition metals, again, that's anything in group 3 through 12. Transition metals have to be in groups 3 through 12. Then you need to include parentheses, and we'll work backwards to figure out what Roman numeral charge should go in those parentheses. We'll do a few here in just a few minutes so you can see what I mean by working backwards. And then you need to write down the name of your negative anion. And this one is the one where if it's off of the periodic table, like oxygen, we need to change the ending so that we have oxide, chloride, sulfide, whatever it might be. If it's off the periodic table, we have those ending changes. If it's a polyatomic ion, then those are the ones that have the extra elements. They're kind of the special ions. Then those we keep the name the way it is. No changes to it. Don't change the endings. The way they're printed is the way they need to stay. All right. So let's take a look at our first one. So you need to be able to divide this up into the positive and the negative half. So Na, sodium, is a metal. So there's our dividing line. This is our positive half, and this is our negative half. All right, and so we know Na is sodium, so we would write the word sodium down. And then MnO4 has to just be one item, okay, one name here. We can't call it manganese oxide, okay? We're not breaking it apart into 3 elements, so it only gets 2 names. It has the positive half and the negative half. MnO4 is a special one. That's a polyatomic ion, so you'd have to look that up on your sheet. And again, you don't have to memorize those, just have your sheet out so you can refer to it. And that is called permanganate. And permanganate, because it's a polyatomic ion, we don't change any endings. They are the way they are. The only other thing that we need to be careful of is sodium a transition metal? And if you look at where sodium is on your periodic table, it's in group 1. And group 1 is not a transition metal, so only groups 3 through 12. So it doesn't need any Roman numerals. So your final answer should be sodium permanganate. Moving on, we have Cu, and then we have NO3 in parentheses with a 2 behind it. So again, we're looking at our first element, copper. We know that that's a metal on our periodic table. So there's our dividing line. So we've got our positive half and our negative half. And Cu is copper. And if you look at where copper is on the periodic table, it's in group 11. So it is one of those transition metals. So that means that we're going to have to put Roman numerals with this one. So I'm going to go ahead and put the parentheses. We're going to need to put a Roman numeral in there, but we're going to wait on it for just a moment. And let's go ahead and at least finish off the second name here. So NO3 has to have one name to it, and NO3 is a special one, again, off of your polyatomic ion list, and it is called nitrate. Nitrate. Now, what is the charge on copper? Okay, this is how you would work backwards and how you need to think about it. Remember that your plus charges and your minus charges have to equal 0. So take a look at copper. How many of them are there? In the formula, there's an understood 1 behind copper, so there's only one of those, and it has a plus charge, but we don't know the number. Now, NO3, on the other hand, is one of your polyatomic ions. You can look it up and notice that it always has a -1 charge. So that means that your copper is unknown. We don't know what this number is, but we do know that your nitrates are a -2. And then all of that has to equal 0. So if you do some quick algebra here, we know that this copper had to have a +2 charge in order for the -2 to all equal 0. So we would put a Roman numeral 2 there. And that is what we should have printed. The next one, we have Fe2SO4 is in parentheses with a 3. No, Fe is iron. We can look that up on the periodic table, and if you're not sure about where we're here at, this is irons are positive, so SO4 has to be our minus. Now we need to look at where iron is on the periodic table. It is in family number 8. That is one of those transition metals, anything in families 3 through 12. So it is also going to need Roman numerals. And SO4 is all one words, and if you look at your polyatomic ion sheet, you'll see that it is called sulfate. All right, now to figure out the charge, kind of do what we did before, only this time, how many irons are there? There's a 2 behind it, which means we have 2 irons here, and we don't know the charge on either of those. They have to be the same, so it's either both of these have a +1 or both of them have a +2. We can't have one different than the other because they're both iron. We have how many SO4s? SO4, we have 3 of those groups. So SO4, we have it 3 times. And each one, if you look at your periodic, not periodic table, your polyatomic ion sheet, are a -2. So total, we are looking at a -6. And that means that the irons have to equal a +6 in order for this to equal 0. But we have 2 irons. So if we need a total of 6, but we have 2 irons, how do we divide that up so that each one can have the same charge? That means each of them had to be a 3. +3 and +3 would give us a +6. So we're going to put a Roman numeral 3 in those parentheses, which is what we have. All right, moving along, we have KCl. Now this one, notice it only has 2 elements, so we know that these are off our periodic table. We have K, which is potassium, and then chlorine. But remember, when it's off the periodic table, the rule was that the ending had to change to IDE. So we would end up with potassium chloride. Potassium, by the way, is in group 1, so no Roman numeral. Our next one, TiSiO3. So automatically you see 3 elements here, so we know we have to have a polyatomic ion. It's the only way we can have more than 2. So we have Ti, which is our metal, that's our plus piece, and then SiO3 is a special polyatomic ion, so it has a special name. Ti is titanium, so you're going to write down the word titanium. And look at where it is on the periodic table. It is in group 4. So that is definitely one of those transition metals where we get the Roman numerals. And we'll come back to that here in a moment. SiO3 has a special name. It is called silicate, and those don't get any ending changes if they're polyatomic ions. All right, so to figure out the charge, we only have 1 titanium, which is unknown, and we have 1 silicate, which is known. If you look at your not periodic table, your polyatomic ion sheet, it's a -2. So we have a -2, and our charge here has to balance out our -2 because we have to get 0. So this has to be a +2. +2 and a -2 would give us 0, so that's how we come up with a charge of 2. H2O2. Okay, this one is a special one. It might look like it's molecular because it has hydrogen and oxygen in it, but this O2 is kind of unique. It is actually a polyatomic ion called peroxide. And this is kind of hard. You have to kind of almost recognize O2 when you see it. So I understand sometimes this one is hard to recognize because we are just practicing. But we would take the H, and we know that's hydrogen. Hydrogen is just in group 1, so it doesn't get any Roman numerals or anything. And then O2 is peroxide. So that's the name of this one. Moving on, we have 3 more. MgOH, we know Mg is magnesium. Remember, the first ones don't get any ending changes. We write them just the way they are. And then OH is a special one. It's hydroxide, and it comes off of a polyatomic ion sheet. We don't do any ending changes. It's already called hydroxide. It already has that ending anyway. That's just part of its name. Now, magnesium is in group 2, so does it get a Roman numeral? Hopefully you said no, because Roman numerals are only for groups 3 through 12. So this is just going to stay magnesium hydroxide. Na2O. So we always, again, start with our first one. Na is sodium. And where is sodium at on the periodic table? Hopefully you found it relatively quickly. It's in group 1. Group 1 do not get Roman numerals, so the only thing we need to do is just name our second half. So remember, we always have that plus side and minus side. So sodium is the positive, and then O is oxygen. But remember, if it's off the periodic table, we have to change the ending to oxide. So we have sodium oxide. And then lastly, we have Pb, NO3 in parentheses with a 4. So for this one, we know Pb is lead. I think we already had a lead example earlier. And lead is actually an exception. So lead is one of those that it's not in groups 3 through 12, but it is one that is still going to get Roman numerals. Okay, so it's kind of unique. And there's one other one that we'll talk about in class. It's tin right above it. So tin and lead are unique. They're not in group 3 through 12, but they still kind of have weird charges, so they get Roman numerals. So we're going to stick the parentheses there, and we'll come back to that. And we know NO3 is nitrate if you look at your polyatomic ion sheet. Now, to know what the charge is, we know that we only have one lead because there's an understood 1 there. But we know we have NO3 4 times. Now you should be looking at what the charge on NO3 is, because it is a set amount. It's always a -1. It does not change. So total, our minuses equal 4. And that means that lead, in order to balance everything to 0, had to be a +4. And the way you write a 4 is to put a 1 before the V, and that means 4. So this one would be lead 4 nitrate. And that will take care of writing names. We're going to be practicing this more in class as well. It is something that just takes practice. So make sure you're asking questions and don't get frustrated or discouraged if it doesn't come to you right away. But you do need to practice, and you do need to ask for help so that I know that you're struggling, and I can come around when you're working and make sure that you're on the right track.